Hello everyone and welcome to this video. So in this program, we will be taking a look at the binary search algorithm and when to use it in your code. I made a video on the linear search algorithm and when to use it to search for an element in a given array, so please check it out if you are interested. Link in the description below. Nonetheless, in this program, we will be taking a look at the binary search algorithm. For the code, we are given a sorted integer array and we have to find the location of a specific number inside of that array. If the number that we are looking for doesn't exist, we will indicate that by printing number not found back to the user. And this program goes over how to do that. Similar to the previous algorithm video, the main point of this video is to highlight when you will want to use a binary search to look for an element in a given data structure, such as an array. As a side note, if you want an in-depth analysis on the binary search algorithm or any other algorithm, from how the algorithm works to its runtime analysis, let me know, and if I get enough people talking about it in the comments down below, I'll be sure to make a video in the near future doing my best to explain the concept to you guys. So back to the video, the main reason why you would want to use a binary search to find a specific element in a given data structure is when what you are searching through is sorted. Simply put, if the data appears to be in some sort of ascending or descending order, you will want to use a binary search in order to find a given element in that stack. The reason is because although you can use a linear search to find a given element in the data, using a binary search algorithm makes the process much faster, in fact, significantly faster. To put it into perspective, let me explain this concept with some numbers. Without getting into too much detail about the specific space-time analysis of a binary search algorithm, note that a binary search algorithm's runtime is log of n. This means that in the worst case scenario, a binary search algorithm will only take log n time to complete its task or find a given element in an array, with n being the number of elements inside of that array. As a reference, here is a visual representation of the runtime analysis of log n compared to n. What you're looking at is how much time the given function will take to complete its task when compared to the size of the input. So on the x-axis, you have the input size. For us, the input size will represent how big our data structure or array is. The y-axis represents the time as a function of the input size for a given function. So let me explain with an example. So if our array is of size 50, assuming the elements are sorted in the array, for a linear search algorithm, it will take us 50 comparisons in the worst case scenario to find the given element. This makes sense, right? If the element you are trying to find happens to be the last number in that array, you will have to traverse all the way to the end in order to find that given element. But for a binary search algorithm, in the worst case scenario, theoretically, it will only take us 3.9 comparisons or 4 comparisons to find that given element. I got 3.91 by taking the natural log of 50. So if you understand the way that the algorithm works, this number will make sense to you, but if not, then you might be a little bit confused. Unfortunately, I do not want to turn this video into a mini data structures and algorithms crash course, so if you want me to explain the algorithm more in depth, let me know in the comments down below. So you can see that having the elements already sorted gives us a huge advantage when it comes to the time that it will take us to find a given element inside of that array. Remember, the only reason why the binary search algorithm was so beneficial in this particular situation is because the array is already sorted. If not, then your best bet is honestly to use the linear search algorithm to find your element. And the benefits gets better as the array grows and gets bigger. So imagine if we have an array of 5,000 elements. With linear search, it will take us 5,000 comparisons in the worst case scenario in order to find an element in that given array. But with a binary search, it will only take us 8.51 or 9 comparisons on average in the worst case scenario to find the same element, assuming that the array is already sorted. So that is very important. The array has to be sorted for the binary search algorithm to be its most efficient. So yeah, that is what I wanted to cover in this video on binary searches. I guess the purpose of these videos is not only to show you how to do a specific thing, like showing you a code for a binary search algorithm, but it's also there to show you why certain decisions are made given certain circumstances. So with that being said, that is it for this video. Thank you so much for watching. If this video helped you out in any way, please consider leaving me a like and subscribe to the video because it helps me reach more people. And I will see you in the next video. Thank you and bye.